Hey, Mr. Ainsworth, I was having some difficulties with my laptop earlier, so I'm on my PC, but that means I won't be able to use my webcam.
Well, you can just talk like you're doing right now. So it's good to see you here. I'm glad you showed up today. You missed a big day on Wednesday. What happened?
I had a dentist appointment.
Did you go into Canvas and watch the class session video?
Uh, Wednesday, I believe so. Let me double check.
There was 7A4 warm up, and there was also a quiz that day. It was kind of a big. I'll show you. Let me open up the Canvas here and show you what I'm talking about,
Okay.
because we had a big day. We did a big warm up, and then afterwards we had a quiz over 7A4, 7A5. So down here at the bottom where it says 7A4 quiz, if you open that up, the class session video is at the very top going over the warm up. And then underneath that, I had a quiz for everybody according to your period, period 6. So did you watch that? Did you notice all that?
Yeah, I do remember watching that now.
And did you submit a quiz?
No, I didn't get the chance to because my dentist appointment, and then the next day I had work.
Okay, so what you're gonna have to do is after school, after we're done here, I'm gonna put up the makeup quiz link, and you're gonna have to take the makeup quiz, not the original one, because I've already graded everything.
Hmm.
Uh, and so after we're done here around 12:30, I'm gonna put up the makeup. I didn't lock this, so you could still access this. And make a little note right now to go into 7A4 makeup. Don't take the original version 3 for period 6.
I
Because I've
actually
already,
have work immediately after class today, so is there any way I can make it up some other time?
well, later on tonight or tomorrow morning, you got to do it quickly because you got other
Yeah,
things
I
to
can
do.
I can do
So,
it tonight. Tonight works.
what do you do for work?
I work in a warehouse. We do like secure document destruction, so industrial shredding mainly.
Okay. All right. Yeah. So when you get back home or tomorrow morning, whenever you got to be focused and ready. So
Yeah.
whenever you're ready, go ahead and do that. And again, I review everything in the warm up video that's still available above there. Okay.
Okay. Thank you.
Yeah, you're welcome. All right. Well, let's greet each other properly here. Good morning, everybody. It's good to see everybody. And well, we got 21 people here. Okay. Listen, if you're going to be with me, I want your cameras on. I know why Alex cannot have his on, but you need to have your cameras on at all times. Just so you know, I've had a lot of difficulty last period with multiple senior students. Uh, Too many people are not turning your cameras on, and they are not there behind the computer screen. And I was so frustrated with a few people last period that didn't respond to me verbally, didn't respond in the chat, didn't respond to me with their cameras on or anything. And so if that happens here, I'm going to remove you from class and you're not going to participate. So we need to have our cameras on at all times. We need to be present mentally and physically. Because I'm getting really frustrated with some people who they're logging in, but they're really not there. And that's a primary reason why people do not have their cameras on, is because they're really not there. And I have too many seniors failing the course because of that right there. They're just simply not participating in any fashion. So Alex, I understand your position right now, but in general, guys, you need to do that. And I hate to start the class like that, but I just had to get that off my chest and before we get started, because I want to have a smoother class session with you guys compared to what I had earlier. It was really frustrating. So that's enough of that. So first of all, it's good to see you guys. And obviously, I finished my grading last night, and there are some strengths that I saw overall. Everybody should be off your phones. Look at the screen here and reading my screen. There are some strengths that I saw overall in your quizzes, and there were some weaknesses. And because I saw a few things, I didn't feel overall my classes were really ready for a full comprehensive hard quiz. over section 7A, over the 5 activities. So we're not quite there yet. That's why at the top I said we're going to delay this a few days and do it on Monday as opposed to today because of what I saw on the quiz results. So today is about addressing the weaknesses here, trying to understand things better so that you perform better later on a quiz or exam. Okay. And I had intervention yesterday. When I graded your quizzes, I asked a lot of you to come and see me. And Grace and a few others came to see me, and I gave those people an opportunity to correct their quiz and resubmit it for a higher grade. And only a few people came, not enough. And I found out later on, and from period 4 and others, that one of the reasons why is that you guys, or some of you guys, or many of you guys, are not looking at my annotations. You're not looking at the comments. And I know that for a fact because I asked a few people throughout the classes today, and I found out they did not know they were supposed to look at the annotations. So let me make it perfectly clear. When I grade a quiz and I take hours, it takes me hours, multiple hours to grade a free response, and I hand grade them digitally on my iPad. You guys need to look at the annotations. You need the feedback. If you guys do not know what you did wrong, you're going to repeat the same mistakes. And is that good or bad? Is it good or bad? Give me some, show me that you guys are listening here. Okay, if you repeat the same mistakes, you're not learning. The only way to improve is to identify your mistakes through help from me. I need to give you proper feedback, which I do. And then you guys got to read it though. So what we're going to do is we're going to start by having someone share their screen and show how to view your quiz, because I've graded every quiz. And by the way, if you missed your quiz, which a few you have, on Wednesday, you need to take the makeup version that I'll put up a link in Canvas. You need to take the makeup, not the original one in version 3 for period 6, but the makeup, because I've already graded everything. So version 3 is not valid anymore. You have to do a makeup. So before we get in, well, yeah, let's do this. So Carson, can you do me a favor and just share your screen? And I want you to show everybody how to view feedback. So let me allow you to do this. So go ahead and take over the screen. Everybody watch his screen here. And I want everybody to do this for your own quiz, because I know for a fact that not everybody's viewing your feedback. So just for funsies here, go to the main module. The mod, okay, yeah, go to home, I guess. Okay, go down. Okay, so open up 784 quiz. Okay, so there are the versions. For period 6, you had version 3. Notice there's no makeup link. Okay, I'm gonna put that in after class today for the people that missed their quiz on Wednesday. And the videos, class session video for the warm up on that day is up there right there. You can see the video at top. Carson, go ahead and hover around the video. Okay, there it is right there. And I go through a big warm up, and then I had everybody take a quiz based upon 7A4 and 7A5. Now, Carson, go ahead to hover around the submission details in the upper right. That's where you see your quiz details, guys. And you need to do that for every quiz and every test. So click on it, Carson, please. Now, you can't see your feedback yet because you have to select view feedback. So click on view feedback. Okay, and so notice that the rubric was out of 10. There you go. Okay, that's fine. Go slowly. Go ahead and maximize a little bit so I can see it better. No, zoom in. There you go. Now slowly scroll down. Okay, so let me see problem number 1. Okay, so a little bit more. There you go. So this is why you guys need to look at feedback. So when there's little things like this, if you don't understand my comments, and so Carson, if you don't understand that, then you need to come and see me during intervention. I know I'll explain things. And then I'll give you guys the opportunity to do corrections and to resubmit. I did that for a few of you in this classroom right here. I'm looking at you guys. A few of you guys came to intervention yesterday. We corrected it, and you resubmitted, and I raised your grade based upon your submission. Carson, go down to number 2. Okay, and the smiley face means it's correct, and so he got a perfect score on number 2. all the different parts were correct, and he got a 5. So go back up to the very top. There are 2 problems, both 5 points apiece, very top. And that's why it's a score out of 10. So you get a 9 out of 10. It's a Rubik score. So I know 9 out of 10 is 90% on a straight percentage, but it's a Rubik score, and that equates to a 95. But the point is, guys, you guys got to view your feedback. So if you haven't done that last night or today, you need to. Okay. Carson, I'll take the screen back, buddy. Thank you. That's what you guys should be doing every time I give you a free response quiz or test. Okay, now let's talk results here. So there were some strengths that you guys had and some weaknesses. So let me focus in on the positive first. Hang on for a second. Let me get them. You can ask questions as we go here too. Okay, so you guys were strong at the following things. Most students know how to identify where it's undefined. That was really good. Most students know how to use Desmos and enter how to function for the most part. Most students know how to describe the behavior of the function values by looking at the graph, but not at the table. That's a weakness. That's what I have to go over today. And number 4, most students know what a removable discontinuity is. So that's good, really good. Weakness, number 1, this is my focus of today's discussion here. Most people had difficulty with the table of values. A lot of people. And so that's today's focus right now. And that's one of the major reasons why I delayed the quiz till Monday, because we're not ready yet. And I want you guys to understand better to the point where you guys can get a high B or an A. I want, my standards are high for myself. My standards are high for you. And we're not quite there yet. So I need to focus on the discussion on that today. That's our main goal today, is to understand that better. Number 2, too many people don't know how to factor a trinomial. Your Algebra 1 factoring skills are weak. You guys should be up here looking at your screens, not your cell phones. Okay. And then, Sophia, are you with me? Okay, you guys should be paying attention right now, not on your cell phones. Get rid of the distractions. That's another problem I've been having. Okay, that's another reason why I want the cameras on, because I can tell whether you guys are focusing on the discussion or not. It's pretty simple to tell usually. And then number 3, and not too many people don't know how to convert a function to a table in Desmos and enter your values in, because I didn't see it when you submitted it. So I'm going to have a student share and do that today. I'm going to have you guys show the class how to do that. Number 4, too many people are taking their phone and screenshotting their screen, okay? And you get this blurry image and submitting that as your Desmos. And that's not how you do it. You go to the print icon and you save it as a PDF. So I'm going to have someone show that, okay? So I can read it better. And then number 5, you need to read my annotations, okay? So let's get started. Today, our main goal is number 1. We want to figure out how to get it to understand what in the world does it mean to be in the neighborhood of the point of discontinuity. How do you pick appropriate values that are close to the point where it's undefined? How do you do that? And so that's a skill that needs to be learned. So get out a piece of graph paper and open up your Desmos account and title your graph paper. You're going to submit all this with your Desmos. So if you don't have graph paper, use whatever you have, but let's get started here. So give it a title, put your name on it, and then I'll forget the second half right here. And get Desmos ready. Log into your Desmos account. I'm going to do the same thing, and I'm going to work with you guys, and you're going to submit everything we do today together here, because our whole goal is to improve, to get ready for your quiz and your exam next week, because it's next week. Okay, and when you log into your account, this is what's going to appear. So you go to the upper left and you click on New Blank Graph, so you can start fresh. And you want to give it a title, and your title should be the same as over here. So pick the same titles, 7A 1 2 3 4 5. Review number 2. This is the second review, so call it number 2, and then save it. Make sure you save all your work. as you develop it in Desmos. Okay, so you have your Desmos open, ready to rock. You got your graph paper and you're ready. Type in ready in the chat when you got both ready and we'll get started. And then later today, after lunch, after we take a lunch break, when we come back to intervention at 1:10 p.m., if you guys need to talk to me about your quiz, you can appear then. And then I'll help you out with your quiz later on. If we need to do corrections, I'll help you. And then you can resubmit for a higher grade. We'll do that at intervention. Okay, that was another reason why I delayed the quiz, because I didn't have enough people. I didn't have enough time to talk to people to help them to correct your quizzes, okay? And because of that, we needed more time. I was trying to help you guys out. Okay, so let's start on your graph paper here. Let's start here. So let's start by starting with a function. We got to work with something. So let me present a function to you. So let's suppose y is equal to 1 divided by x plus 4. Let's do the analysis first. Okay, and we'll get to Desmos later. Okay, so let's start with what you're good at. Most of you guys on the quiz showed me that you know how to figure out where the function was undefined at. You were good at this. This was a strength on the quiz. So help me out. Where is this function undefined? And you could turn your mics and talk to me today a lot. That'd be quick. I could talk Estella about that at the end of this right here. And next time, put that out to the class. They need to see that too. That was good question. So I can address activity 785, no problem. Okay, so it's undefined at -4. Very good. At x equals -4. Okay, more importantly, why? So I want someone to just explain in words why. So use your mics now. Okay, it's because you can't divide by 0. If you substitute -4 in here like this, if you put -4 in, you get 1 divided by -4 plus 4, which is 1 divided by 0. And that, my friends, is undefined because you can't divide by 0. You were strong at that. That was a very good, I saw good strength on the quiz. Another thing that you guys are pretty good at was this right here. Once you know that, now you know this. What's the domain? And I want this in words first. Just turn on your mic. Someone help me out with that. How do you say this?
All reals except -4.
There you go. This is the kind of participation I want to see. So all reals except -4. Okay. And mathematically, symbolically, you write it like this. X is not equal to -4. That's how you write it symbolically. And then let's use interval notation. This is going to be on the comprehensive quiz too. How do you write this using interval notation?
Negative infinity, or sorry, in parentheses, -infinity to -4, and parentheses in unison or whatever with -4 to positive infinity.
Okay, so open interval from -infinity to -4, union, an open interval from -4 to infinity. Very good, Sophia. Okay, I think that was Sophia, yeah? Did I get that right? Okay. So that's the domain. Now, is this a removable discontinuity or non-removable discontinuity? Or not sure? Removable or non-removable, or you don't know what I'm saying? Be honest with me. Be honest with me. Type in not sure if you're not sure. I need some feedback here. What?
It's non-removable.
Why? I agree with that, but why, Austin?
Because there's no removable discontinuity.
How do you tell though if it's not removable?
If nothing cancels out.
Right, you can't factor and cancel anything out. There you go. Okay, very good. Read the chat, you guys. Very good. So this is called a non-removable discontinuity. Okay, it's a non-removable because you can't factor and cancel, because you cannot factor and simplify, basically. So that tells us something. What does that indicate? What do we have at -4? Do we have a whole or do we have a vertical asymptote? Which one? Okay, so let me read what you guys are saying here. So what kind of asymptote, vertical or horizontal? There's two types of asymptotes. Paige, I got your message. Thank you. Okay, so vertical asymptote. So this tells you whenever you have a non-removable discontinuity, that's important right there. That tells you you have a vertical asymptote. If it was removable, then it's a whole. If it's not, you have a vertical asymptote, okay? And its name is x equals -4. Okay, so now is, okay, now let's go to the table of values. So let's make one here. So we need to figure out what happens as we approach -4 from the left and for the right. So let's go down in the middle of the table. We know it's undefined here. We'll put these in Desmos later, but we need to talk about what are the appropriate values to put in the table from the left, and what are the appropriate values to put in the table from the right. This was a weakness on the test right here. This is what people struggled with big time. Right here. What does it mean to be in the neighborhood? So this is where I want to pause and really spend some time right here. So what does it mean to be in the neighborhood of -4? And we need to talk about it. So because you have to understand that this is a key concept. This leads into your first subject of calculus called limits. What does it mean to be in a neighborhood of -4? Meaning very close, very, very close to -4. And when I was working with a few people yesterday, I did something different. So I'm going to draw a simple number line. So work with me on this. So I'm going to draw a simple picture here. And this really helped other students, and it's been very effective today when I've been working with everybody throughout the day. So we know that -4 is between -3, and we know it's exactly halfway between -3 and -5. We know that. But we need to pick values to the left of -4 on the left side that are close to -4. So let's pause for a moment. Let's go back to the very basic number line that we grew up with here. And let's pick values to the left of -4 that are close. And let's start off with the simplest value that you're very familiar with. What's the midpoint between -4 and -5? What's the midpoint between -4 and -5? There you go. So it's -4.5. Let's put it exactly in the middle. Now, believe it or not, that's not in the neighborhood. That's not close enough. Okay. Give me another decimal that's a little bit closer. Not super close, but just a little bit closer. Come on, guys, start typing. Give me some numbers. So you got to participate. Okay, now watch this. Now everybody stop right there. Stop, everybody. Let me take a look at that. Now, let me show you something. -4.9 is here. This is why I'm doing this. -4.9 is close to -5. That's what happened in the quiz. A lot of people didn't know where the decimals were, and you fill out the table in all kinds of weird ways. And so today our goal is to better understand this concept right here. -4.4 is a little closer. -4.3 is a little closer. Negative 4.2 is a little closer. Okay, now we're getting kind of close, but we're still not in the neighborhood. What's closer than negative 4.2? There we go. Negative 4.1. Negative 4.1. Now we're in the neighborhood. So let me get my highlighter out. Let me show you something. When you're this close, I don't know why people are leaving the class here. You guys should not be leaving. That when you're in that yellow region right there, that means you're in the neighborhood. When you're super close to a number, oh, Ian, now you're getting really close. Okay. Now you're in the neighborhood. So let's get a little closer here. Ian, you just got super close. So closer than, but let's not get that close. Back up a little bit. Now, Mark, you're really super close. I mean, like you're so close, it's not even funny. But if a little closer than negative 4.1 is negative 4.01. And then what Ian put in and Mark, it's so close that it's kind of hard to graph. I mean, negative 4.001 is closer. If you want to get even closer, negative 4.0001. Those are super close on the left-hand side. It's negative 4 and a teeny bit. What Ian put there, the way you say that is this number right here, negative 4.0001. It's negative 4 and 1/10,000ths. And as you know, that little fraction right there, that's a very, very small number. Okay, so those are numbers on the left-hand side. So we can put those in the table. You could start off with negative 4.5 if you want in Desmos, but that's not very close. It's not in the neighborhood. Negative 4.2 is closer. Negative 4.1 is closer. Negative 4.1. Now you're in the neighborhood. 4.01. Negative 4.001. Negative 4.0001. Now you're talking. This is in the neighborhood of negative 4. That's what you want. If you want to start at negative 4.5 in Desmos and then get closer to negative 4 on the left-hand side, be my guest. But you got to be getting really close. And you got to use values like what Ian and Mark put up there in the chat. But not everybody understood that in the quiz. And that's why I'm spending time today to do that, because it was not very well understood. Okay, that's why I delayed the quiz. I want to get a better understanding here today. Now let's go back to the number line. On the right-hand side, okay, so let's go on the right. I need a number. Let's start off with something easy. What's the midpoint between negative 3 and negative 4? Midpoint first. This you should know. What's the halfway point between negative 3 and negative 4? There we go. Let's plot it. So, but that's not in the neighborhood. It's not close enough. Okay, so let's get a teeny bit closer, a teeny bit closer. Not super close, but teeny bit close. Get a little closer to negative 4. Type in some numbers, guys. Get a little bit closer. Okay. Now, if you negative 3.9, that's getting closer. I mean, negative 3.6 would be a little closer, but negative 3.9, now you're in the neighborhood. Okay, see? Now those numbers are closer. So what's closer than that? Well, negative 3.99. That's a little closer than negative 3.9. You want to get closer? Then go negative 3.999, put 3 nines in there. And then Mark's got the closest one there. That's super close to negative 4. Okay, so let's put those in the table. Okay, so here we go. So we start off with maybe negative 3.5, negative 3.9, negative 3.99, negative 3.999, and negative 3.9999. That's getting, now these numbers on the right, these guys are pretty darn close in blue there. Those are in the neighborhood. So when teachers or mathematicians say, hey, you want to be in the neighborhood of a number, we're talking about pick a number that's extremely close. Who's following me today in our discussion? Because too many people on the quiz did not. So this is why I'm taking the time out today. Okay, because those are the numbers that you want to put in Desmos. Okay. So let me see, we talked about where it's undefined, the domain, we got it, vertical cost. Okay, now we go into Desmos. Here we go. Work ahead of me now because I'm going to ask one of you to share your screen. So start typing. So type in the original function and get ready to share your screen. You're going to submit all this after we're done anyway. So, okay. So we have our function there. We need to also put these values in. And here I want one of you guys to share a screen. I'll take a volunteer here first. And if I don't get one, I'll choose somebody. I prefer a volunteer. Can someone help me out here?
I'll volunteer.
All right, Mark, go ahead. Go ahead and share your screen.
Just so I don't have the equation written on it yet, so I have to type it out.
It's okay. It won't take long to enter. So if you want to still do it, that'd be fine. Now everybody should be doing this simultaneously. We're going to work through this whole thing. So Mark, go ahead and enter that in there. Okay, very good. On the next line, type in oh, okay. So no, duplicate it. Go ahead and duplicate it. No, okay, delete those. There we go. Okay, so actually, I want you to go through that again. Delete that. Delete the second one. But I want you to go slower. So start over again. Click on the gear icon. Go slow. Now duplicate it first. Now on the second one, click on convert to table. Very good. Now go down. This is undefined at -4. So go down to where it says 2, +2 in the table. +2. Change that to a 4. Excuse me, -4. Right. So now backspace it. Just backspace. Go all the way. Clear all those out by backspacing. Just keep backspacing. Yeah, okay, so now let's enter in those values. Go ahead and type them in. The ones we came up with earlier here. Ooh, change. There you go. Okay. Now just hit the enter button. It'll give you a space for another one. So get closer. Now there, get really close. One more, get really close. Okay, now go underneath -4 and type in the rest of the numbers. Start with -3.99999.
Okay.
Okay. All right. Next one. Get a little further away. Oh, -2. Or excuse me, -3. That's what I meant to say.
I don't have the bottom one written down yet, so I don't know them.
It's all right. Just type in -3.99. Hit enter. -3.9. And then get further away. Go to -3. I don't know, 5 or something. -3.5. That'd be fine.
Okay.
Okay, cool. Now, type in your vertical asymptote at -4. Very good. Now you need to change your zoom level on your browser. In the upper right-hand corner, there are 3 dots. Change that to 80%. There you go. Now, there you go. Go to, let me grab this. Let me screenshot this. Let me steal your work here. Good job. So give me a second here. Let me grab this here for a second. All right, Mark, very good. Let me have the screen back, please. Good job there. Okay, so what we have Okay, so this is his work right here. So we have the table, we have the vertical asymptote, we've got everything here. So now let's talk function behavior here. So our point of discontinuity is at -4. We have a vertical asymptote there, so let's label a few things. So right here, we have a vertical asymptote at x equals -4. Oh, you know what? I want to show you guys something here. Let me, Mark, go ahead and take the screen back over. I want to show the class one more thing that you guys might think is pretty cool. Some people have already figured this out, but I wanted to show everybody. Evan, I think it was x plus 4 in the denominator, so I think we're good there. Okay, so go to your vertical asymptote on row 3, and then hold your cursor down on the blue circle. There you go, hold it down. And then select dotted line. Look at, select the second one. There we go. That's how you make your asymptotes is dotted lines, guys. Just wanted to show you that. So, very good. Thanks, Mark. Let me add the screen back here so I can talk about that. So that's how you make your asymptotes look like dotted lines where they should be, because they're imaginary lines, and that's why we draw them as dotted lines. Well, what's going on here? Let's talk function values. So here we go. When we're on the left-hand side, when x approaches -4 on the left, what are the y values doing? So as x approaches -4 from the left, -4 from the left. Let's go around the classroom here. Estella, what do you see? What do you see here? What are the y values doing when you approach -4 on the left?
The y value is decreasing.
Towards what?
Sorry. It's
I agree with
decreasing
that.
towards the right.
No, from the left, they're decreasing. It's going down on the graph. And look at the y values in the table. -2, -5, -10, -100, -1,000, -10,000. They're decreasing and they're approaching what?
Negative infinity.
Yes, they're getting
Yeah.
more and more negative. Very good. Okay, and what we say in words, guys, and let's add the words to this. When you say y is approaching negative infinity, what that means is they are decreasing without bound. Write those words down. It means that they are going down. There's no bound. There's no minimum. This function goes down forever, okay, because it's asymptotic to that vertical line at -4. So when we say y goes to negative infinity, we use the word decreasing. They get more and more negative. They decrease. They go down as opposed to up, okay? So that's what negative infinity means. When you approach negative infinity, you are decreasing without bound. Now on the right-hand side, something's different. So when you approach when you approach -4 on the right, come in this direction here, on the right-hand side, something else happens. So let's see here. No. Matthew, are you there? Here we go again. This is what has been happening too much. This is why I hate looking at ceilings. Because usually when I get ceilings, that means they are not there. And I see 4 or 5 ceilings here, or ceiling fans. And this is what's killing students. They're logging in and running away. And guess what? Those students, all those students that are doing that on a regular basis are doing very poorly. And that does not make me happy. Okay, so let's get focused here. So on the right, Ben, talk to me. You're here. What's happening as x approaches -4 from the right?
It's getting as close to the line as possible, but never actually touch it.
That's true. It's asymptotic. But what are the y values doing? When x approaches -4 on the right, what are the y values doing? Look in the table. Look in the
Decreasing.
table. Increasing or decreasing?
Decreasing.
Well, look in the table. 2 to 10, 2 to 10 to
Okay.
100 to 1,000.
Increasing.
Yeah, look at the function. It's going up. On the right-hand side, it's going up. On the left-hand side, it's going down. And if it's going up, it's got to go to infinity. Look at the numbers from 2 to 2. Look at the table. This is what I'm talking about. This is what people struggled with on the quiz, you guys. And that's why I'm taking time out today so that you guys understand better. Sophia, are you paying attention? From 2 to 10 to 100 to 1,000, it's going to infinity. They're getting bigger and bigger and bigger because the function's going up and not down. I know, Austin. The attendance, the senior attendance has been very poor lately. And guess what? Grades have gone down overall because attendance has gone down. People are not responding in the class because they're disappearing. That's why I'm being I'm giving this message. That's why I'm a little bit different today. Is because the student behavior is changing and not for the better. Let me tell you guys, we only have a few more months to go, and you cannot drop off the bandwagon now. You worked 4 years in high school. This is your last year in high school, and you cannot blow the last portion of your senior year. I have about 3 or 4 students in every class that are doing that. And that is not a good thing. You want to stay strong. You want to work hard. You got to make yourself proud. And if you don't pass the course with a B or better, how can you leave? How can you graduate with any pride? You know, you gotta leave with good grades so you can end strong and say, hey, you know what? Not only did you survive high school, but you survived the senior of online, which is something no one else in history has ever done before. And if you do that, then you can be proud of yourself. Okay. Okay. I think we're good on that one. Now there's more to things. One example is never enough. And so let me throw you a curveball here and show you something you haven't seen yet before. There are functions that have both holes and asymptotes at the same time. So let me present this to you here. So second function. Let's suppose we have you're gonna like this one. Check this out. X minus 5 divided by x squared minus 3x minus 10. Now this is an interesting one because it has both a hole and an asymptote. The question is where. So I bring this one up too because a lot of people had trouble factoring a trinomial, which is an algebra 1 basic. So let's figure out how to factor this. Everybody start working on this. Now, again, there's multiple methods here. Some of you guys I know use the box method. Some of you guys use FOIL method, which is what I do most of the time. Some of you guys know how to factor by grouping. There's like 3 or 4 methods possible here. No matter what method you use though, you guys have to know that you have to be thinking what 2 numbers multiply to -10 and add to -3. You have to know that. Because if not, I don't know how you're going to figure this out using any of the methods. Because all of them require that. Do you guys know what 2 numbers multiply to -10 and add to -3?
Sorry, did you want us to answer that out loud?
Oh yeah, you can talk to me anytime you want. I prefer that actually.
Okay. -5 and +2.
Let's see if she's right. So -5 times 2 is -10. So far, so good. And then -5 plus 2 is -3. So Sophia, I agree with you. All right, but how do you use that? Oh, here we go. Talia, put that to everybody. Don't be shy, put that to everybody. Okay, and you guys need to know that the factors of negative and 5 and 2 are used in your factoring using the FOIL method. First times first gives you first. X times X gives you the X squared. And then using those factors, the -5 and the +2, look at that. These factors just go right in there. -5 times 2 is -10. L stands for last in FOIL. That's the FOIL method right there. Now, what was also kind of like not really understood was like, what happens? What is this equal to? We're not done yet, guys. What is that equal to? I'm taking time on all the aspects of the quiz that were kind of weak overall. What is that equal to? Do you agree with that, you guys? Look closely. You're close, Toya. Got to modify it. You see? This is why I'm doing this with you guys. I want a better understanding of things from you guys. It's when you simplify x minus 5 divided by x minus 5, you get 1. Anything divided by itself is 1. Put a 1 in the numerator. This is not equal to x plus 2. It's equal to 1 divided by x plus 2. Talia, does that make sense? Talk to me. Does that make sense or not? Because I can't see you.
Yeah, it makes sense. I just forgot to put the 1 on the top.
Do you think that's a big deal?
Yeah, because it changes the equation of
Yeah,
finding.
exactly. Okay, so all right, as long as you understand. Okay, so now the new function, the new simplified function looks like this. 1 divided by x, actually, we got it up there. 1 divided by x plus 2. Okay, so now let's dig a little deeper before we get to decimals. We're not even there yet. What does this tell us right here? When we cancel out the x minus 5, what does that indicate that we have? Okay,
Discontinuity.
Yes, and Carson agrees with you. I agree with that. It means that we have a removable discontinuity. I agree with that. What does that imply? Okay, and that, Alex, you brought that up too. Alex, you can put your comments in the whole chat because that you had a good intuition. Whenever you have a removable discontinuity, you have a hole. At what point? X equals what?
X equals -2.
Try again. That's where it's undefined at -2, but that's not where the hole's at.
It's at x equals 5.
Try again. Oh, no, I'm sorry. That's good. That was correct. I misheard you. Sorry. Jumped the gun there. So why is it 5?
Because it has to be the opposite? I don't know. Like you have to set it equal to 0 and that's where the hole is. I'm not sure.
Okay. All right. So if you take x minus 5 equal to 0, you get x equals 5. Yeah, it's what makes it 0. So the hole's at x equals 5. So it's at 5 comma something. Now, let's talk about this. How do you find the y coordinate? Where's the hole? Because just talk to me, guys. Turn on your mics. Let's just have a discussion here. Because this is, again, today is to better understand how to find or determine when you have a hole versus an asymptote and how do you define the location. Because Desmos will not tell you.
You could plug it into the simplified equation.
Next, and again, some of you guys are messaging me privately. Don't be afraid to put it out to the class because it creates discussion. So yes, Carson, we substituted into the original function because the original one's not defined there. It's undefined at 5. And it's also undefined at -2. It's undefined at 2 points. So we have to substitute into the new function. So the new function, f of x, is 1 divided by x plus 2. So we have to evaluate the new function at 5. So Talia, go ahead and put that to the class. You had a good idea. So she said substitute in the simplified function too, just like what Carson just said. So what is that? So you substitute 5 in, you get 1/7. So the whole is at 5, 1/7. Desmos will not give you that number, guys. It will not tell you where the whole is. Okay, so it's undefined at 5. It's also undefined at -2, and that's what Mark brought up earlier. Mark, are you seeing the difference between a whole and the other point where it's undefined? Because you mentioned -2 earlier. That's where it's undefined at -2, but that indicates something else. It's undefined at -2. You were right, it's undefined there, but what does that tell us that we have?
So we have an asymptote, right?
Right, because you can't remove it. You can't factor this anymore. So this indicates you have a vertical asymptote at -2. So if you can't remove it, it's non-removable and you have an asymptote. If you can remove it, that tells you information where the hole is located. Who sees the difference between the two? That's only 2 or 3 people. Look closely right here, guys. If you can remove it by factoring and simplifying, you have a hole. If you can't simplify it, it's non-removable. This is non-removable. Okay, and that indicates you have an asymptote because it's undefined at -2 because you can't divide by 0. So if you can't simplify it, you can't remove it, you have an asymptote, vertical. If you can remove it, you have a hole. Do you guys see the difference? Because it's really important here because you got to make decisions when you do this on your own, which you will next week on test day. Okay, you got to make good decisions. Okay, now before we get to Desmos, we know that it's undefined. Okay, at 2 points, x equals 5 and at -2. So we should be able to state the domain now, which is a key concept in mathematics. It's huge. It's even huge in calculus. Oh, why do people keep disappearing? Oh, I hate that. What's the domain? If you know where it's undefined, then you know what the domain is. In words. This is going to be a repeated question on the test because it's important.
The domain is undefined, then is
I can't really, whoever's speaking, I can't really hear. Oh, Mark, that was Mark speaking. Go ahead and maybe speak into your mic a little bit.
I didn't realize my mic was on, and I was like thinking about it in my head.
Oh, that's good. You're thinking
I didn't even realize my mic was on.
Oh, it's okay. It's all right.
Yeah.
Speaking out loud as you're thinking is a good thing. I like it. What's the domain, you guys? In words.
All reals except 5 and -2.
There you go. Every function starts with all reals as a domain, but if there's a restriction, you got to say except whatever the numbers are. And it's undefined at 5, it's undefined at -2. So you say all reals except 5 and -2. And the way you write this symbolically is you say x not equal to 5, comma, -2. That's how you write it symbolically. Okay, now that you have all that, see, look at that. Even before you use Desmos, this is what you got to do. You got to do a lot of thinking. Desmos will only help you so much. You have to know what you're doing to be successful next week. on both the quiz and your exam. You have to really fully understand. That's why I'm taking today out, to reach a higher level of understanding so that you guys are going to be better off and you can, you know, achieve your goals of be better. Okay. Now, this is where I'm going to ask you guys to share your screen. So put your function in. Type your function in. Make sure you put your parentheses around your numerator so the function gets entered correctly. So it's going to be x minus 5 divided by x squared minus 3x minus 10. So when you want to deselect the previous function, turn your previous function off so you only see one function at a time. Okay, at this point, I need someone to take over because I want you guys to share your screen and show me how it's done. So who would like to show me that they've learned something here and can handle all this here? Take a volunteer first.
I can share my screen.
Well, Mark, you've been doing that a lot. I want someone else to demonstrate Desmos. You've been doing awesome. You're going to be doing this on your own, guys. You might as well make sure you know how to do it with me, because if not, I can help you. You're testing Monday and Wednesday. Guys, you're being shy. Come on. Marissa, do you have the ability to share on your computer? Okay, so let's do a couple things here. Go ahead and we'll modify the table in a minute. Go to the next, go to row 6 there and enter in your asymptote at x equals -2 on the row 6. There we go, very good. We'll go into your table. Oh, there you go, very good. Let's modify your table of values. So it's undefined at -2. So go ahead and go down in the table and change the bottom 2. Just change that one to -2. And we'll put the undefined point there. Change that to -2, and then go up 1, and then just backspace it, and we're going to change those values. If you put your cursor at 1 and just backspace it, it'll clear those out for you. Just keep backspacing, backspace, backspace. Okay, now stop. Okay, okay. That was one too many. That's okay. Go ahead and hit return. It should. Okay, now let's get really close. Put in your values. Let's get really, let's go on the left side of -2. So start at, give me a decimal to the left of -2. Okay, get closer. Hit enter. Okay, get closer. Get closer. Okay, very good. Okay, that's coming in from the left side of -2. Now go underneath in the next row past -2. Let's come in from the right side. So we need to go down, just hit enter a couple times, and okay, now let's start at -1.5. No, go down to the 4th one. Leave some room because we'll approach it from the right. Okay, so start at -1.5. Okay, now go up 1 and get closer. Get closer to -2. Get closer, go up and get closer. Oh, no. Yeah, there you go. Now, one more time. Get really close. Get close. Okay, very good. Very good. Okay, now, go into, let's change your browser zoom. Go in the upper right-hand corner on those 3 dots. Yeah, good. Saved it. Go to 3 dots and change your zoom on your browser. Upper right, to the right. And change your zoom to like 80% or so I can see more of it. Click on the 3 dots. No, okay, there you go. And then, okay, so now on the left-hand side, go into row 7. Underneath your vertical asymptote, let's type in your hole. So there you go, parentheses. And now the hole is at 5,17. So type that information in. Everybody should be doing this simultaneously, by the way. Click on label. Turn on your label. Type in hole at 5,17. Very good. Now put your cursor on the circle on the left. And no, not, oh, okay, you can do that. There you go. Very good. So use the gear icon. Very good. And then, awesome. That's everything we need. Now scroll up a little bit so I can see your function at the top of the table. Okay, and go, I need to be able to see your hole as well on the bottom. So scroll up a little bit, or scroll down a little bit. Okay, that's fine, right there. Keep it there. Let me screenshot that. Good work. These are the skills that you guys need to be able to do on your own. This is why I'm having students do this versus me. All right, Marissa, I'll take the screen back. Thank you very much. Good work. Okay, so let's bring this in. This is her work now. All right, so let's finish up on this one here. So we know we're coming in on the left side of -2. X is doing something, Y is doing something else. So when we're coming to -2 on the left, as X approaches -2 from the left, what in the world's going on? So Colin, can you help me out with this one?
Well, I can sure try. I don't know how well I'm going to do, but I can sure try. All right, so from the left, so X is heading towards -2, and then the Y values are going downwards. So it'd be Y towards -infinity.
Okay, and because the function's going down, and you can also see that in the table as well. -10, -100, -1,000, -10,000. I mean, this is getting more and more negative. And do you remember how to say that? What does Y approaching -infinity mean?
Isn't it all reals? Oh, no, it's not. I can't remember how to say it mathematically. I know you told me, but I can't remember what it was.
Okay. Here's look at the previous example.
Decreasing within bounds, right?
Without bound.
Without bounds, excuse me.
Yeah, there's no minimum, okay? There's no minimum here. So if you're decreasing, which these numbers are decreasing, there's no bound. I mean, if you're going to -infinity, they keep getting more and more negative and it never stops, okay? So we say decreasing without bound. Make sure you're writing down the vocabulary because you're going to see this on your test next week. I'm going to be asking you guys to respond in this kind of vocabulary. I mean, that's part of the mathematics. We got to learn how to write it, say it, you know, and write it in words, write it in symbols. I mean, you name it, everything. Okay, so on the right-hand side, something different's happening. Kylan, that was good, by the way. Okay, when you're coming in from the right, Y is doing something else. So Okay, so Brianna, can you help me out on this one? What do you see in this example here when you're coming in on the right of -2?
From the right, y goes towards positive infinity.
And so y goes to positive infinity. And what does that mean to you? What's happening with it?
It increases outbound.
Very good. So the opposite of decreasing is increasing, and it's going up, 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 up. It keeps going upward to infinity, and that means it's increasing without bound. That means there's no max. That's what without bound means. No max. No max. Keeps on going, never stops. Good job, Brianna. Okay, so that was the function behavior on this example as you approach the asymptote at -2. Those are all the different skills that you need to be good at. And that's why I'm taking today to time out to give you more experience, more practice, time to think about it, work with it. Know the difference between a hole and an asymptote. When do you have a hole? When do you have a vertical asymptote? So let's pause here and reflect. Any questions up to this point? And if not, give me a response either on the screen or in the chat, one of the two. Giving you guys a chance to ask questions and think about it.
Since there's a hole in this function, do we have to make a hole for or do we have to make a graph for the neighborhood around x equals 5?
Oh, you could, and then the y values would approach that 1/7 in the hole. I am not going to do that right at this point. I'm just going to focus in on the function behavior around the asymptote. If I asked that on the quiz, you could do that. But in this example, I just wanted to look at the behavior around the around -2. So it all depends what's asked for, Glider. You can just respond according to what's asked. In this case, it's going to just be around the behavior around the vertical asymptote as opposed to the hole, but you could. Okay. We only went through 2 examples, but I was focusing more on quality of understanding than quantity. Any questions up to this point? Okay, then let me repeat what the plan is. Okay, get your calendars and let's write a few things down on your calendars. So, because you may not remember what everything I say next week. Okay, I even write down notes and I have my own calendar, so make yourself a calendar. So next week on Monday, the quiz is not today. I said it's postponed. I had it up here on the screen. So that now the comprehensive quiz over the 5 activities is on Monday. I'm going to publish it in the morning and give you all day to do it. Plan 1 to 2 hours for this one. It's going to be multiple questions covering the entire 5 activities. So it's comprehensive. So write down Monday quiz on 7A 1, 2, 3, 4, 5 comprehensive. Plan 2 hours, 1 to 2 hours. I say 1 to 2 hours because I don't know. It all depends on your skill level. Some of you guys might finish in 45 minutes to an hour. Some might take 2. It all depends on you, and I have no idea. So it's going to be due at midnight. So I would definitely not start this too late. I have some people like working at night. I wouldn't suggest doing that. Not only that, if you have an issue, I'm not going to be available at midnight. I'm not going to be available even at 10 a.m. or 10 p.m. If you start early and if you have questions, then you can correspond with me on Monday and I'll be able to correspond with you during the middle part of the day. So I would not suggest you start late because I'm not going to be available later on in the evening. That's on Monday. Wednesday is you're going to get immediate feedback on this on Monday. It's going to be a multiple choice selected response in Canvas. It's going to give you immediate feedback, and it's going to tell you whether you know the material or you don't. If you score poorly, you need to see me during the intervention on Tuesday. So write this down. Tuesday, there'll be intervention from 1:10 to 2:30, like it is every, after school every day, Tuesday through Friday. I know that's my other class day, but I'm going to be able to work with you guys too. And all you have to do is talk to me, let me know you need together, you need some help. I can analyze questions in your quiz. That's easy for me to do. And we can take a look at that. Then on Wednesday, it has to be Wednesday. It's got to be your 7A test. I'll put all this in Canvas, but I want you to write it down. It can't be Friday. Do you guys know why? Do you know what's going on next Friday? I'm asking just because some people know and some people don't. You know what kind of day we have on Friday? I heard that. No, I don't know. I don't know if it's a day off. It's a short day for some reason. I forgot the reason, so I'm gonna have to research it myself. But I think the classes are going to be way shorter, and because they're going to be way shorter. Really, Sophia? I doubt we'd have a short day because of that, but it's going to be a short class day, so you need the full 90 minutes on an exam like you normally do. So write down Wednesday, section 7A, 1 through 5 test. That goes in the test category, as opposed to the homework category. And so that's the plan. So if you need I'll be available Monday. If you need a Zoom with me, I can do that after my meetings in the morning. I can Zoom with you in the second half of the day on Tuesday as well. Even though that's not technically your MRWC day, I can meet with you. All you have to do is request it, let me know, message me and remind and tell me that you want to meet, and I'll be happy to meet with you guys. Okay? Any questions or needs before I let you go? I mean, I could even meet with you over the weekend if you need additional help, but you just have to ask. Okay. Well, listen, you guys enjoy your weekend. Go through Canvas, make sure everything's complete. You dial everything in. Everything has to be complete before test day. You know that. And then you guys have a good weekend. Let me know if you need anything. I'll keep track of my phone and keep checking my messages. So you guys have a great weekend. Give me some smiles out there and have a good weekend. Relax a little bit too. All right, get your rest. Okay, and take care of your body. Take care of your mind. Important. Okay. All right. See you guys.
Mr. Ainsworth?
Yes.
I was a little bit lost on the 7A5 activity. So I didn't.
Oh, yeah. Oh, shoot. I forgot to address that. So let's do that now.
Okay.
Thanks for reminding me. I forgot about that.
Yeah. It's
okay.
Like,
so do you have a specific one we want to look at? Part 1 or part 2?
Part 1.
Okay. Let me pull it up. Pick one.
Wait, let me see my graph because there was one I was particularly stuck on. E.
Okay. All right, let's do it. Let me enter this in. Okay, and hopefully you did too. So you said E.
Yeah, I didn't get it because there were like 3 different lines. So
Okay.
I was confused on the whole asymptote. Like,
no worries. I'm glad you brought this up. So let me put this in. Hang on, I got to adjust my settings here. Okay, so y equals 1 divided by x squared minus 3.
Yes.
Okay. Holy cow, look at that crazy looking thing.
Mm-hmm.
Okay, cool. All right, so now, does it look like it has 1 asymptote or 2?
Probably 2, because yeah, that doesn't seem like 1.
I mean, it's let me screenshot this and show you something, for a second. Okay, so it probably has asymptote, a vertical one here, whatever this is, and one here. Do you follow what I'm saying here?
Yeah.
Okay, just keep your mic on so we can discuss things. Okay, so the question is what's this number here? Where are these, it's x equals something, right? So we got to figure out where it's undefined. So you know that the denominator can never be equal to what? What's the only number you can't divide by?
0.
Right. So we can't let this ever be 0. So the question is like, what number squared minus 3 equals 0? What number squared minus 3 is equal to 0? Can you think about one?
The square root of 3 to the second. Yeah, that, because they cancel each other out, and 3 minus 3 is 0.
Very good. That was really good number sense. So if you wanted to solve it, this is what you would do, okay? But you used very good number sense. So when you square root both sides, you get this. So not just root 3, but negative root 3 as well.
So it has to be 2 of them because there's plus and minus. Okay.
That's right, there's 2 of them. So x equals negative root 3 is on the left, x equals positive root 3 is on the right. So watch this. Let's go into Desmos and type them in. So x equals square root of 3. Oh, do you see it up here? Do you see that? Look at that. Do you see it in purple on mine? I don't know what your color is. The color doesn't matter, but do you see it up here?
Yeah.
Okay, now let's type in the other one. So x equals negative rad 3. Look at that. So you have vertical asymptotes at x equals rad 3, at x equals negative rad 3. That's where it's undefined.
Gotcha. So those would be the two asymptotes, and then okay,
So
I think I get it now.
So that's what you would enter in here. Okay. And then you have to do the behavior thing. So like in respect to negative root 3 here, when you're coming into from the left, so as x approaches negative rad 3 from the left, what do you see for the y values on this graph?
It's going. It's negative infinity, or?
Look right here. I'm going to go on from the left side of the vertical line. So as you see, that's what put your cursor on the graph, and it's called tracing the graph. And as you approach the asymptote, aren't you going up?
Yeah.
So y approaches positive infinity on the left as x approaches negative rad 3 from the right. Now you're on the right. So now I'm here. Look at my graph. Now you're on the right side of the asymptote. Look what the function's doing. Is it going down or up?
Down.
So you say y approaches what?
Negative infinity.
Ah. And then you can analyze on the other side, on the other asymptote.
Wait, but what about the shape at the bottom, the upside down?
Yeah, the middle portion.
Yeah, because they're both going down.
Yeah, but you're only concerned with what happens when you approach the vertical asymptote. So if you're in the middle part of the function here, watch this. And let's say you're approaching the asymptote on the right side, like at root 3. As you approach root 3 on the left side, The y values are going down to negative infinity.
Mhm.
Now, if you grab a point on the right side of the vertical asymptote,
Oh.
so on the right side, as you approach √3 from the right, what are the y values doing?
Increasing.
That's why Desmos is so bitchin', because you just grab a point on the graph and you get close to the asymptote and you're either going up or you're going down.
Yeah.
There's only two options for these asymptotes. And so you just approach the asymptote from one side, approach the asymptote on the other side. And if you're going up, you're going to positive infinity. If you're going down, you're going to negative infinity.
Okay. I think I get it now.
It takes practice. You
Yeah.
you click on the graph and you trace it and you approach the asymptote and ask yourself, are you going down, decreasing, or are you going up, increasing? And it's either one of the two. Unless you have a hole, that's different. This function doesn't have a hole.
Yeah.
Okay. Okay. And that's what you want to do with all these crazy functions in here, even the one with the square root. If you like on the next one on f, let me just do f real quick. Let's just put it in and take a look at what it looks like. So y equals 1 divided by,
The square root of x to the second minus 3.
right. So it doesn't matter how crazy they look. Desmos will graph anything,
Mhm.
which is kind of nice. Okay, now notice we have two vertical asymptotes probably again. And again, look at the denominators. In E, the denominator is x minus 3. In F, it's the square root of x minus 3. Don't they look similar?
Mhm.
They're going to have the same domain. It's the same analysis as what I just did here. You can't let the denominator be 0. So you do the same analysis in F as you did in E. So in F, there's going to have the same asymptotes, √3 and negative √3.
Okay.
See, that's why number three says, what are the similarities that you notice? Some of them have the same asymptotes and some of them don't. Why? Because they have the similar denominators.
Oh.
Oh, look at G. G has a similar denominator. Look at that. So if they have similar denominators or similar parts, they're going to have similar maybe asymptotes or where they're undefined. So you're trying to discover by using Desmos here, what similarities do they have in their asymptotes? What differences do they have in their asymptotes? Does that make sense?
Yeah. I
It's
think
great.
yeah, that was mainly like that that problem right there kind of just helped me out for the rest of them. Like, because that was probably the most difficult one for me because of the different lines. Like, I just saw it weird last night. I don't know, but it makes sense now.
I don't know, it takes a lot of practice and again, the feedback, the discussion that you and I are having, if it can't happen in class because we're going through a different activity, then it occurs in an intervention, right? And that's why more people have got to come to intervention and ask good questions like that. So, because then you'll get feedback. And then we have an intelligent conversation. And then what you do is you take that, you run with it, you go back to it on your own, and then the light bulb will get brighter and brighter. And then maybe we might meet again over the weekend. Who knows, right? I mean, you'll have to let me know. And if I keep on saying this to the class, if you guys need to meet again, you guys know how to get a hold of me. And then we just keep having these discussions, and then you'll get through it.
Hopefully.
You will. You work hard. I'll work hard on my end, helping you, and the two. I'll point you in the right direction. Trust me.
Thank you.
You're welcome.
All right. Bye.
All right. Have a good weekend.
You too.
Mr.
Okay.
Ainsworth, I have a couple of questions. So for late work, I've recently had like something bad happen to my family, so I've had a hard time submitting some work on time. But I'm this weekend I'm gonna try to get caught up. I turned in like 5 late assignments for your class the other day. Do we need to email you when we turn in late work, or do you just get a notification?
I get a notification, and then usually on the weekends anyways, I go back to the beginning and I look for any late work, and then I'll know who submitted their late work. So you don't need to notify me.
Okay.
Because I go take care of that once a week. And if something bad happened, you should have, you can go in and talk to me privately in intervention or on the side, and let me know what's going on, if I can help you out in any way.
Okay. Sounds
You know,
good. And then for the makeup quiz, I have to go to work right now, but I get off at 5. Will it still be open for me to take when I get home?
It'll be
Okay.
available all evening, so you'll have time.
Okay. Sounds good. Thank you.
You hang in there, and I'll talk to you more later.
Gotcha. Have a good weekend.
You too.
Sorry, mine was kind of like his. I've been struggling a lot lately, like the past couple weeks, and I've never had. I'm a straight A student. I've never really had problems turning in my homework, but I have quite a few missing assignments for your class. And the past couple weeks has been like really hard to get like motivated to stay on track, and I've been having a lot of like projects for a bunch of my classes. This weekend's kind of the only weekend that I've had lately that's like pretty empty and chill that I can actually catch up on work. I was wondering how like far back I'm allowed to go for late work, because I think I only have late work from like the past 2 or 3 weeks was the max. I was just wondering what the cutoff kind of is.
The cutoff is, I don't want you to go back to section 5.
Okay.
I'd prefer you to stay focused on section 7. We've gone through 5 activities and a lot of preps.
I
So-
think that all the ones I'm missing are section 7.
Good.
So can
That's
I
good news.
turn all of those in?
Yes, if they're, just make sure they're quality, because I'd rather see quality work than like half-ass work. You know what I mean?
Yeah,
Make
yeah,
sure
yeah.
it's really good. And if you need help with it, then that's when you give me a call over the weekend. I know I'll be available throughout the weekend at certain times.
Mhm.
Give me a call if you need more help. We can always go back and revisit something, Zoom a little bit. I can assist you in certain, whatever you're working on. And then when
Okay.
you're ready, throughout the weekend, just submit things one at a time as you work through them. And
Okay,
I'll
thank
help you
you.
along the way. I know this. It's the same thing with what I said with Alex. If there's something in your life that's affecting you and you need to talk to me about that privately, you can see me later on today. And it's kind of helpful to have students talk to me and tell me what's going on, because I don't know everything in your personal life. And
Yeah.
if I have a better understanding of what's going on, I have more compassion, and I just understand better. I can better serve you. So you can decide whether you want to talk to me later on or not. That's totally up to you.
Okay, thank you.
Sounds good? Okay. Thanks for letting me know. I appreciate that. And then we got Kylan. Go ahead.
Okay, so I got 100 on the last quiz, and that kind of shocked me because I knew I was going to do well because I prepped, but I didn't know I was going to do that well. So I am in the same boat as Sophia. I have I'm focusing on the recent stuff that I've been missing, and I'm trying to get some of that turned in, which I have done so far. So I should be able to send you a bunch of stuff tonight. The only problem is I got my computer to work here, running it off my phone because I'm in Boulder City. I drove in at like 1 last night. So I can't print. My printer here does not work and the library is closed. So I can't print stuff off. And I'm trying to figure out a way around that. So can I screenshot or even share a Google Doc with my Desmos graphs and work on that? So that way I don't have to worry that it went down.
So in the printing thing, are you talking about printing your Desmos work? Is that what you're concerned with?
Yeah, because I can't print anything, so I can't upload it through like Adobe Scan like how I would at home. So is there a way I can just like share a Google Doc about it, or just find a way around that? Because I don't want to get marked down on points just because I can't
Oh,
submit the
It's
graph.
actually it's actually easier than that. Okay, so look at my screen. So I don't want, because some people are taking their phone and taking pictures of their computer screens, and that's what I was kind of laughing about earlier. I don't want you guys to do that. So this is what you do. Like anything on Desmos right here, you can do this. So in the upper right-hand corner, do you see this little share icon here?
Mm-hmm.
Now you don't share the hyperlink because I cannot use the hyperlink in the comment section in Canvas. It's not an active hyperlink when you do that. So what you do is you click print. Now I know that you don't have a printer, so listen closely. Now when you're in a hotel, I assume?
House.
House, okay. A friend's house?
No, my grandparents' house. We just moved here. I'm sitting on an air mattress. We have no furniture. Like it's the.
Oh, okay.
Yeah.
Got it. Now I understand. Okay, so since there's not going to be a printer icon coming up here when you hit the dialog box, but when everybody should have this option right here. It should say as an option, save as PDF.
Okay.
Now, can you do this right now with your Desmos right now? Can you go?
Yeah, let me see.
Repeat what I'm doing here. So go to the upper right, hit your share icon, and then click on the print option. Not the hyperlink, but the print. And you should see this dialog box come up.
So for me, it gives me the option, Microsoft print to PDF. That's the only one.
That's it. Okay, now what it's going to ask you to do, let's do this simultaneously here. When you select save, it's going to ask you where you're going to put it on your computer. And I was hope to God that you guys have a MRWC folder. Yeah, I can tell you don't.
No, I don't, but I'm a paper person. I'm not a tech person. This is far out of my realm.
Okay, I know, I'm teaching you now. So what you're going to do is click on your desktop. Okay?
Okay.
Okay, now at the top, it says new folder. Click on new folder. Okay, and guess what you're going to call it?
MRWC?
Holy cow. Okay, now on that, okay, hang on. Oh, I have one that's already called MRWC. So let me call it MRWC2. MRWC2, because I already have an MRWC folder on there. So you say open, and then you say save, and it's going to save it in there. This is where you're going to save all your work in your MRWC folder. Holy cow.
Okay.
Okay. Now, then what you do is you go to your Canvas, and then you open up your review right here. And it doesn't look this way on your end, the student side.
Right,
you can submit multiple documents. So you scan your work that you just created today, that looks like, this right here, all of this stuff. Oh no, wait a minute, where's today's? Right here. So all of this work here that we created today, you scan this. Oh, okay. Oh yeah. So you scan that using Adobe Scan, that goes to a PDF, you upload it, and then you can upload as many PDFs as you want. So then you click on another submit, and then you go to the MRWC folder, you click on your PDF that you created with your Desmos graphs, and you upload that. And so on my end, I'll see two submissions, two PDF submissions. One is going to be this right here, your work, and the other one's going to be your Desmos. And everybody's been doing that like weekly, daily. That's how everybody does it. So you can submit as many PDFs as you want. And I want everybody to go paperless because there's no need to go waste paper or ink. Not only that, some people don't have printers like you. Okay?
Just this once for the next 2 weeks. Don't worry. I'll probably end up with one when the movers come with all the stuff. So.
Yeah, I know, but some people
I know.
they haven't moved and they still don't have a printer, or they ran out of ink, either one. And that's how you go paperless.
Okay.
All right. Did I take care of everything? We're good?
Yeah, I think that covers everything so far. So thank you.
All right. So work hard over the weekend. Get a hold of me if you need to.
Will do.
All right, see ya. Okay, Gabby, you're being patient. Talk to me.
Hey, Mr. Ainsworth. So basically, you told me, like, you told us, like, just to talk to you if anything's happening. So basically, I'm straight A student, just like Sophia. I hold myself to, like, the highest of high standards. Like, my mom's a teacher, like, dad, straight A student. He's taking college courses. I just hold myself to that high standard. So this whole online thing kind of sucks. I'm also old. Like, my big brother moved out recently, so like a family thing, and we just moved houses, and like I have not even unpacked. Like, I have boxes just around my house, and I recently, like the past 2 weeks, I have been so unmotivated, and I'm also like really busy, like taking care of my little brother and everything. Like, I just have not had time to like sit. I come to the classes, but as soon as like I hang up, I have to go help unpack stuff and I have to help move. Like, it's been crazy. And the only thing I've been thinking about is like, oh my goodness, like these 7 out of 10s are probably going to bring me down to a B. I'm already at a B. And in my head, that's like bad, but I know it's not. So I just hope that, I don't know. I don't really know what I'm asking for. I'm just like letting you know that I'm trying to get stuff done, and I'm not purposely like not turning things in because I don't care, because I do.
Well, you're one of those kids that stands out in my mind that you do care, because I know that you interact with me in class. I know that you participate verbally, participate in the chat, and you really try to over the year. I know that. And I also know and realize that a lot of, I'll say people, because it's students and teachers, it's not just students, are struggling with the online thing, because it's not normal. And
It isn't. Like, I see it through my mom, and everyone's struggling.
Oh yeah. And it's you're independent. You're required to do everything on your own with no teacher kicking your butt at school. I mean, usually, like in the past when we were at school, you know, sometimes when the kids get in, you know, when they start slacking, the teachers get on you a little bit. You know, we do a little butt kicking and a little bit of push and motivation, and that's normal stuff that happens, and you're not getting much of that now. Either you succeed or you don't, and because we're online, it's hard for me to come to you and say, hey, what in the world's going on here? Come on, get your act together. You know, what can I do to help you? And, you know, motivate you and push you at the same time, because we do a little bit of both. Like today, I'm sure you've noticed a little bit different Ainsworth, because I was getting a little bit, you saw a little bit different Ainsworth today.
Yeah, and I agree. Like, it is frustrating when you are asking someone a question and they're not even there.
Yeah, and I've been struggling with that, and people have been falling off. And so you saw a little bit of different personality from me today, because I needed to do a little butt kicking on some people, and I'm going to have to also call some people after this and saying, hey man, you can't be doing what you're doing here, because you're not going to be successful. But bottom line is this: I know it's tough doing the work and making it all happen, and trying to stay motivated, because no one's really motivated. But let me give you a piece of advice that I've learned in 53 years of being on the planet. Okay, and because I suffer from this too. I mean, I'm a person just like you, so no one's exempt from procrastination. No one's exempt from lack of motivation. No one. I don't care how old you are. I don't care even if you're a teacher. It doesn't matter. But I do know this: that action precedes motivation. And you should write those three words down right now, both of you. Action precedes motivation. And I challenge you guys to put that on the wall, because there are a lot of things you're not motivated on, but you'll never ever get motivated to get started. However, if you start acting and start producing and start working at it, the motivation will start happening. And let me give you an example from my perspective on that, so you can kind of understand what I'm saying. 2 days ago, when I gave you guys that quiz on Wednesday, okay, it was a free response, okay? And I have 100 seniors. I have to grade 100 free response papers. Do you know how long or how many hours it takes for me to do that?
A long time.
Take a guess. Guess how many hours it took me to grade 100 free response papers.
Like 6 hours probably.
It was between 4 and 6 hours. Okay. And then a 2-page test or a 3 or 4-page test. Oh my God. That it's like an enormous amount of time. So what happened was I'm not motivated to start grading papers at 4 p.m. when I have to cook dinner for my family. I want to spend time with my family, my wife and my son. I also want to relax. I want to break. I am not motivated to grade. However, I knew that I had to get these things done before Friday because you guys need feedback, as I keep on saying over and over again. And I don't think it's right for a teacher to hold that back and to take forever to grade papers and give you results back 2 weeks later. Teachers that do that should be reprimanded because that's not good. And because of that, I had to get it done quickly to give you guys feedback. So, and I wasn't motivated. I'll just be straight with you. But I sat down after school was out. I got a little snack and I sat down. I do my grading on my iPad. That's how I do all my digital grading. I have a digital pen. I do all my grading here. And that's how I do it all with you guys. And I sat down on the couch, got comfortable, and I got a little snack to keep things going, and I just started going. And after I got halfway done, about the 40th or 50th student, I started feeling good. Started feeling okay, and I see the light at the end of the tunnel here, and I started getting motivated. And I didn't get up to do anything else. I didn't get up and get distracted. I didn't answer my phone. I didn't go anywhere. I got 2 classes done on Wednesday night. And then on Thursday, I started finishing period 6. And so it's 4, 5, and 6, just that's the way it is. And I finished yours in the evening on Thursday. And then, so Friday, I felt good about myself. I got all the results in. I gave you guys feedback. I met people from periods 4 and 5 on Thursday afternoon. I felt pretty good. And the motivation increased because I started being productive. I started acting. Action always precedes motivation because you'll never get motivated just out of the blue. It never happened. But as you complete your assignments this weekend, as you girls both get caught up, okay, you're gonna feel better and better of yourself when you do that and you start submitting. And what I would recommend is like list out your goals. What do you want to accomplish in MRWC? Write a list of everything that you have to do, and then structure out your weekend. I'm going to complete this one in the morning on Saturday, and then I'm going to take a break. Then I'm going to complete this one in the late morning, and then I'm going to go have a little bit of fun. I'm going to take a break. I'm going to go do some exercise. I'm going to go meet a friend, and I'm going to have a little bit of fun. And then in the evening, I'm going to nail these 2 out. So you make a schedule, you plan your weekend out, and you just don't do it all right in a row, 4 hours straight. That's not healthy and it's not good. But you spread it out over the weekend. You got other subjects too that you got to think about. So when you plan out your weekend, you plan out, okay, I got to do this right now. I've got English here. I've got government over here. I'm making this up because I don't know what you have. And then you structure out your weekend and you start checking them off. And as you start checking them off, you go, oh yeah, this is starting to feel good because you're productive, you're acting, you're producing. And then as you start doing that, you're going to go, I'm over halfway done and I still have time left in the weekend. If I get it done early, then I can have free time and relax. And all that stress, all that weight off your shoulders, it's going to make you feel better and you're going to sleep better. You know what I mean? So you get organized. You write down everything that you guys have to do. After you do that, very good. You get a calendar out. Organize your day. Organize your entire day with times. I'm going to do this here, here, and here on Saturday. I'm going to do this here, here, here on Sunday. And then I'm going to do this here, here on Monday. And then start doing a check off. And then let me know how it goes.
I do appreciate teachers who will like see that, like, or who care, because I have a couple who they don't care. Like if you don't get your stuff turned in, you don't get your stuff turned in. but I like the teachers who are usually like, okay, if you're like struggling here, tell me what you're gonna do about it, and then I'll let you turn in all your stuff. You know what I mean? Because like what you just said, I did that. But I'm like trying to be better. But I know it's like really hard to get there, but I made myself go to the store. I got some like post-it notes, and that's why I put that thingy up on the wall, and some lists, a new little planner, and some nice colorful pens, and I'm ready to do the work over the weekend. But I was wondering, what is the cap on the amount of points that we can get?
It's usually a 7 or 8, depending on the quality of work.
Okay.
And it really depends on quality, but no higher than an 8. And it just goes down from there depending on what you submit. The higher
Okay.
quality of, if it's really good, it's a 7. If it's really, really good, and I look at the whole thing, and you submit your Desmos work, and you really are thorough in your activity, whatever you're submitting, it could be an 8. But I don't go higher than 8 on light work just to teach you guys a lesson. Because there's no penalty on things, then people don't learn. You know what I mean?
Yeah.
There's got to be a consequence. So it's a 7 or an 8. Yeah, I mean that's normal.
It's better than a 0 or a 1.
But even 7s are, if you're consistently a 7 on your homeworks all the way throughout, you're gonna have a hard time. You can't get an A probably. You're gonna eliminate your potential to get an A. And then if you're late all the time, usually what happens is, what I've seen is that people don't test well because you're always constantly behind. And kids that are always constantly behind usually don't test well. And if you don't test well, forget an A. And some of the people forget a B. With a couple, 2, 3 people, they're not even over 70. So you want to get caught up ASAP. And then as you do that, remember, it's all about quality. And if you're not understanding, what are you going to do? What are you going to do if you're not understanding? Talk to me. What are you going to do?
Oh, sorry. I thought it was more like sorry.
No, I'm asking you and Gabby, what are you guys going to do if you're working through your late work here and your activities and you flat out don't know what's going on? What are you going to do?
Well, you said that we could text you about it, and then we could like talk about it and figure it out where we're going wrong.
Right, Gabby? Yeah, just because it's the weekend doesn't mean you can't call your instructor. It's a little bit different than regular school. I don't usually say those things in regular school, okay? Usually when Friday night hits and you guys leave the school at 2:30, 3 o'clock or whatever, I'll say, I'll see you Monday. But we're online and we're doing this. We have Zoom and so it's a little bit different. I'm more available than I normally am. So you guys do your part, work hard, I'll assist.
Sounds good.
And then if you want to give me some, you're welcome. And if you guys want to shoot me some text throughout the weekend to stay accountable, like to remind, tell me how you're doing. I'll respond back to you. That might be helpful too. We'll do that, and I'll check my phone throughout the weekend, and I'll be doing teacher stuff too as well, but I'll be happy to keep you guys accountable, keep you guys motivated, and talk to you guys throughout.
Okay, thank you.
Okay, all right,
Thank
girls.
you.
Good discussion.
Have a nice weekend.
All right, see you guys.
Take care.
You too.